Hello, scholars, and welcome to our lesson on composition of isometries. This is in transformations in volume and is part 1. And the goal is that you'll be able to understand what the term isometries is and be able to find compositions of isometries. Our reason for working on this is that geometry quite literally helps to shape the world around us. Being able to understand and use the methods to move and change shapes is incredibly important and helpful to understand the world we live in. Let's begin. First, with a warm-up pop-up. Looking at the moving red piece in this game of checkers, how would you use transformations to describe its movement from beginning to end? So it'll start fresh, looking at our red shape here, our red checker piece. How would you use transformations to describe what it is doing? Doing a check-in. There are a few different transformations you could use to describe what's happening. Because the red checker piece is kind of hopping over the blue pieces, you might be inclined to talk about reflections and say, well, it reflected over one piece, then it did the next piece, and then the last piece. There are a few different ways you could also do this. I think reflections do make a lot of sense, though, for what the piece is doing. Let's clear this up and actually talk about what is an isometry. An isometry is a transformation that preserves distance or length. In other words, are translations, reflections, and rotations. It is another term or word for transformations that result in congruent similar figures. So our flipping, sliding, or turning, as we know, make congruent figures. And isometry or isometries is just another word for those transformations. Now that we know what an isometry is, it's just another word for our congruent transformations. What's a composition of isometries? A composition of isometries is two or more congruent transformations, or it is when two or more congruent transformations happen to the same figure, one transformation after the other. They can be written using sentences or functions. So we have a transformation or composition of some isometries happening here. First it's being rotated, then it's being translated. In a sentence, we could say rotate triangle ABC 90 degrees counterclockwise, and then translate triangle ABC up 4 and 2 left. In function notation, we have the T for translation, -2 being 2 left, 4 meaning 4 up. And this open circle here, that is it kind of looks like a multiplication symbol because it acts in a similar way. It is combining in a very special way these two transformations. Because the other thing it does is get rotated 90 degrees. Now, one thing to take note of, in function notation, we actually do our transformations right to left. So we do them backwards. We rotate this first, then we translated it. Let's actually do an example here. It says, the fish on a boat's sonar. Oh, I'm going to want to get my pen out to put some important moves here. The fish on a boat's sonar moves, it says 3 units right, and it says 2 units down. It then moves 5 units left and 1 unit down. If the fish began at the coordinate 0, 0, what are its new coordinates? So, step 1, perform the first transformation on the point. They have 2 transformations here. First, it's 3 units right and 2 units down. So why don't I do that real quick? And I'll keep it in blue. It said 3 units right, so my fish is right here. It moves 1, 2, 3, and then it says 2 units down. So 1, 2. This is the current point my fish is at, but we're not done yet. That was the first part of the composition. We now have the second part. It then said it moves 5 units left and 1 unit down. So 5 units left. 1, 2, 3, 4, 5. And then 1 unit down. 1. This is the final point of my composition of isometries, which was step 2, doing the second transformation. And this is huge. I did not start back at the beginning. I continued from my last moved point. We go in order, and we're always going from the last point we started with to do the next transformation. Now it did ask for the actual coordinates. So for the final coordinates, I'll do it in purple. We were at an x value of -2. So -2, comma, and we were at a y value of right here, which is at -1, 2, 3. So -3. These are my final coordinates after I did the first transformation and then the second transformation. In this case, they are both translations. Make sure to pause if you don't have your notes in, but I'm going to clear up and go to the U try. So for this one, it says, you are working for a space research station and are in charge of guiding an astronaut on a planet who is struggling to find her way safely back to base due to a storm. You instruct the astronaut to move 4 units up and 2 units right to avoid a pit. You lastly guide her 3 units up and 5 units right. If she began at 0, 0, what are her final coordinates? Alrighty, I am doing a check-in, so be ready to check your answer or pause if you're not ready. So taking note here, you first instructed her to go 4 units up and 2 units right. So if you first took our figure here and moved them 1, 2, 3, 4, and then 1, 2 units right and stopped here, you did your first transformation successfully. The next part is that you have her move 3 units up and 5 units right. So doing that, if you went up from the last point, 1, 2, 3, and then went 5 units right, 1, 2, 3, 4, 5, this should have been the final point you guided her to. They did ask for the coordinates though. So on the x value, if you successfully moved her successfully, we would have been here for our x value, which is at positive 1, 2, 3, 4, 5, 6, 7. I'll put it over here. We had 7, comma, the y value is here, and that's at positive 1, 2, 3, 4, 5, 6, 7. Oh, so she's at 7, 7. And if you had also had that she ended up at 7, 7 for her final coordinates, it means you did this composition of isometries correctly. Make any corrections if you need to, but I'm going to clear up and go to our closing for part 1, which is that isometries are transformations that result in congruent similar figures. So just a new word for something we've already known about. When we do multiple transformations, one after the other, it is called a composition of isometries. With that, I'll be seeing you in part 2 on our lesson of composition of isometries.